Hi, hello everyone, welcome to Jet2 Mastery. In this video, we are going to discuss the solution of special subsequence AG. The problem description is you have a given string A having uppercase English letter. So you have to find how many times subsequence AG is there in the given string. Okay. So task is very simple. We need to count how many times subsequence AG is there in the given string. Okay, so return the answer modulo. Okay, for our final answer we need to mod with 10 power 9. This is 10 power 9 plus 7, as the answer can be very large. Okay, so problem constraint, that is fine. Input format is a string, output format is an integer. Okay, let's take, so this is our given string. Okay, in the string how many times AG is present? See, G one time. Okay, then AG, this called 2 time. Okay, AG 1 time, then AG 2 time, and next time AG 3 time. So my output should be 3. Okay, so here we have one condition. What is that condition? I'll say the condition is, so my I less than j and my string of I should be A and my string of j should be G. Always my I should less than j, which means, okay, let's take my A. Okay, this is my A, where all my G is present. So my G is present here and here. So the first count is 2. Okay, so this is your ith index and this is your jth index. So your I always less than j. Okay, so you no need to consider this A and this G, because I here, j here. In this case, j greater than I greater than j. Okay, so you no need to follow this condition. So your I always less than j. Whenever you are finding A, so you need to pair up j after this ith index. So that is the point it says. Okay, so now let's think about the brute force solution. Now think about the brute force solution. Okay, first let's write the index value here. 0, 1, 2, 3, 4, 5. Guys, you need to carefully listen. This is string. This is not an array. This is string. But string is also called of character array. Okay, so whenever you are finding A, okay, suppose you are finding your A here, what is the brute force? You need to start from here and you need to count how many J's are there. How many J's are there? J count is 2. What is that? This one and this one. So this A can be pair up this G, also this G. Okay, so count initially your answer equal to 0. So now whenever you found 2, so your answer will be answer equal to answer plus count. So that is 2. Okay, now let's move to next. So currently your answer is 2, right? Now you are checking next A. Where is your next A is there? My next A will be there. So I am counting how many G's are there. Only 1 G. So previously my answer will be 2. Right now answer plus my count, that will be 1. So now my answer is 3. Is it? Now my count is 3. So answer of this case, that will be 3. That is nothing but this A is pair up this G, also this G, and this A is pair up this G. So totally my answer will be 3. Okay, so now let's see the second example. Okay, my A is there. How many G's are there? 1 and 2 and 3. So finally 3 plus, where is my next A? Okay, my next A will be there. So only one count is there. After that only one count. So my answer will be 3 plus 1, that is 4. In this case, that is 4. Okay, now let's take the last example. Where is my A? Okay, A is there. After that how many G counts? 1, 1, 2, 3. Okay, so answer will be 3 plus, where is my next A? My next A will be there. How many G's are there? Only one G. After this A, only one G. So 3 plus 1 plus, where is my next A? My next A will be here. After that only 1 G. So 3 plus 1 plus 1, that is 5. In this case, our answer will be 5. So guys, have you got any approach? The brute force approach is just whenever you will find A, just iterate from I plus 1. Suppose this is your ith index. Just iterate from I plus 1th index to till n minus 1th index. Count your G. Okay, that is the brute force solution, right? So that will take, that could be order of n square. In the worst case, that could be order of n square time complexity. But as per our given, we need to solve, because what is the problem constraint? So the problem constraint is 10 power something. Okay, so but we need to solve in order of n. That is possible. Now think, how we are going to solve that. Okay, now the approach is very simple. Okay, very simple means, so you might think, can we create the prefix array for G, right? That is the one approach. Yes, that is one approach. Can we create the prefix array for G? So that prefix array will be tell, do you want prefix array or suffix array? You need to tell, do you want prefix array or suffix array? So can we create the suffix array of G, which means whenever you are in I, okay, whenever your A is there, okay, this is your ith index. So this index will say till from this point to this point, I plus 1th index to n minus 1th index, how many G's are there? How many G is it? So my suffix array will give the answer. But if we create the suffix array, what is our space complexity? Our space complexity will be order of n. So in this problem, we are going to solve our time complexity is order of n, that is linear time complexity, and space complexity is order of 1, constant space complexity. Okay, so whenever we are thinking prefix array and suffix array, also we need to think the concept of carry forward. Okay, so carry forward. Okay, here we are going to discuss about the carry forward. What is carry forward, right? The next $1 million question is, what is carry forward? So carry forward means, so we are carried our output, we are carried our whatever the value we need, we are carried till the end of iteration. Okay, so my approach is, guys, please be listen very carefully, it's very interesting. So whenever I am finding A, suppose I am finding A, instead of iterating from this location to this location, why don't we iterate from right to left? Why don't we iterate from right to left, also maintaining my G count? Is it? Also maintaining from right to left, maintaining my G count. Okay, maintain in every ith point, I am maintaining my G count. So whenever I will have a, I'll just pair up. I'll just count my G count. Is it? Okay, let's check. I'll say the approach. Okay, see, first my I is there. Here I need two things. One is my G count, also my answer. Okay, initially my answer is 0. So my I is there. Is my current index is G? Is my current index is G? Yes. So I will increment my G count as a 1. Okay, now let's move. Okay, is my current index is G or A? Is my current index is A? That time I need to add the G count with my answer. Okay, answer equal to answer plus my G count. My G count is 1. Is it? Because this A and this G can be a one subsequence, right? Now let's move to my I. Okay, what is my current index? My current index is G or A? My current index is G, so I need to increment my G count as 2. In every time incremented by 1. Okay, now let's move the next index. Okay, current index is, it's not A, also not G. So just move, because we need to calculate only A and G. My current index is also not A and also not G. Now let's move. So now let's move to my A. This my current index is A. So whenever you will find the A, you need to add your G count, right? You need to add your G count. What is your G count? Your G count currently 2. So your answer will be currently that is 1. So 1 plus 2, finally you will get 3. Why I am adding 2 G count for this A? Because this A has a subsequence of 2G. One is this G, also this G. So that I am adding 2 here. So my answer will be 3. Okay, can we check here? Okay, let's take the G count. Initially 0. My answer equal to initially 0. Here our answer will be 3. That is correct only. Okay. So now, okay, my G, just increment my G count. Now next my I, whenever I will find A, just add my G count to my answer, that is 1. So this is G, so increment my G count. Okay, this is D, leave it. This is G, increment my G count. Okay, so this is G, C, so leave it. So this is A. Whenever I will find A, add my G count to answer. So 1 plus 3. So finally my answer will be 4. Is it? So my answer will be 4. What is that? This A can be pair here, that is count 1. And this A can be pair of 1, 2, 3. So that I have added 1 plus 3. Okay. So now last approach, last question guys, please stick with you. Then next question is, so next thing we are going to straight away do coding. Okay. So G count. So my G count is initially 0. Answer will be initially 0. Okay. So G count incremented as 1. So A means, so add my G count. So 0 plus 1. Okay, my answer will be 1. How I am saying 1? Because this will create the one pair. Okay, this is my A. Also add my G count. My G count is 1. So 2. My answer is 2. Because this A also can be pair up with this G. So my answer will be 2. So I, G count. Increment your G count as 2 from 1 to 2. Again G count. Increment my G count to 3. A means add your answer. Currently your answer will be, add your G count. Currently your answer will be 2. So 2 plus 3. So plus 3. Why I am adding plus 3? Because this A can pair up here, here, also here. So I am adding 3 in this case. Okay, next. No, it is C. It is B. Finally my iteration will end. Finally my answer will be 1 plus 1 plus 3. That is 5. My answer will be 5 in this case. Okay. I hope you have understood this approach. Now it's time towards the solution. Okay. Let's read the input first of all. So our input will be okay. So scanner SN equal to new scanner system.in. Okay. Also let's read the string str equal to SN dot next line. Okay. Now I got the string. Okay. So now what I need to do, I need the 0 count. Also I need total sum int answer equal to 0 and int G count. So G count. Okay. Next, for int I equal to my string dot length minus 1. I equal to string dot length minus 1, which means last index. Then I greater than or equal to 0. I minus minus. Okay. Let's check your character. If str dot char at of I, if that index can be either G or either A, right? If it is G, you simply add your G count. G count plus plus. Okay. Else if, so your str dot caret I, which means the current index. The current index is equal to A, add your answer equal to answer plus your G count. That's it. So apart from nothing, whatever the things B, E, you don't need to perform anything. So finally return your answer, right? That's it, right? So but here we have one more condition. So return the answer modulo. So finally we need to do modulo with our answer. So what is our modulo value? 10 power 9 plus 7. So int my modulo value is integer of 10 power 9, right? 1e9 plus 7. 10 power 9 plus 7. So finally mod with this answer mod. Okay. Now let's think, if our ABEGAG, if our string is ABEGAG, our answer should be 3. ABEGAG. Let's try. Okay, let's check. ABEGAG. Return answer mod. Incompatible types for the return values. Okay, we cannot return anything, right? So we can print. So let's print system.out.println. Run. Else if variable G count might not have been initialized. Is it? Int G count. Okay, G count. Initially the G count value is 0. Okay. Now run. Okay. So what is the input? I forget, guys. ABEGAG. ABEGAG. So ABEGAG. Is it? Yes. The answer will be 3. Now next will be ACG. I'll write it in somewhere. ACG DGAG. AC. Run. ACGD. ACGD. After that, what is ACGD? GAG. Answer is 4. GAG. Answer is 4. GAG. What is our answer? Answer will be 4. So the final one we will verify, then we will close it our program. Compiling program. BCA GG AAG. BCA GG AAG. BCA GG AAG. Okay. BCA GG AAG. What is our final answer? That should be 5. Yes, we got it, 5. Let's check the given input also. ABC GAG. Answer will be 3. This GAB. If we have a GAB, what is our answer? Our answer should be 0. We'll check. GAB. GAB. My answer should be 0. Yes, I got it, guys. So this is our output. Okay. So I hope you have understood this problem, guys. Okay. If suppose you have any doubt, or if you want me to explain further, please ping me on command. I will definitely reply. I will catch up you in the next interesting problem, guys. Until then, bye bye. Take care.